Hey guys, I wanted to go over homework number 3 for you, and a lot of these test questions are going to be very similar to what you're going to see on your test for pharmacology class, and some of these are kind of similar to some of the items that you might see on the VT&E. So I just wanted to go over it and make sure everybody was all on the same page. We're going to start off with some of the easier stuff about converting percentages to decimals, decimals to fractions, fractions to percents, that sort of thing. But don't forget, whenever you're working with those percentages, you're always working with 100%. So if I'm going ahead and convert this 65% to a decimal, I'm just simply going to move the decimal place over 2 spots. So it's going to leave me with 0.65. And now, if I want to take it down to a fraction, that would be 65 over 100. And then you can reduce that further down, so that would make it 13 over 20. Now for this next one, convert 1.7 to a percent and a fraction. This one you've already got a 100 in there, and then you've got a 0.7. So we know we already have 100 somewhere in there, but then we've also got the 0.7, so that would be 70. So that leaves me with 170%. Now, if I want to take it down to a fraction, I'm going to put this down here, so 1.7. I'm just going to move the decimal place over 2 spots. Oh, no, I'm a liar. I am a liar. So to put it into a fraction, ignore that. Sorry, I was doing percentage again. To put it into a fraction, you are going to say I have one whole, so 1, and then you have 70 here, so 70 over 100. And then you can reduce that down to 1 7/10. Now for this next one, you're going to convert 2/9 into a decimal and into a percent. So for that one, it's not even with the 10s and the 5s. So for this one, you can go ahead and just divide 9 into 2. And that will give you 0.22222. It just kind of continues. So my decimal place would be 0.22. And then to turn it into a percent, move your decimal place over 2 spots to give you 22%. For the next one, they're asking you to go from ounces to kilograms. And you guys are really good at already doing pounds to kilograms and kilograms to pounds. So we can do the same thing with this one. The only thing we need to do is convert your ounces into pounds. So how many ounces are in a pound? 16. So you had 237 divided by 16. And let me grab my calculator here and make sure I'm mathing it. So 237 divided by 16 gives me 14.81 pounds. All right, so now I want to get that down to kilograms. So I'm going to go ahead and take 2.2, divide that into 14.81, and that will give me 6.73. So 6.73. All right, so drams to tablespoons. So for this one, you're going to have to know how many drams are in a tablespoon. So I'm going to help you out here. So for every dram, it is 0.25 tablespoons. Okay, so now I'm just going to go 110, multiply that times 0.25, which gives me 27.5 tablespoons. There we go. All right, so Tallulah, she's got a script of 20 megs of prednisone. She's going to get it every day, twice a day, 10 times, or for 10 days. Our clinic only has 5 milligram tablets. So how many do we need to dispense to Tallulah? All right, so some of this you don't need. Some of this information is useful, some of it is not useful. We do know that she needs a total of 20 megs per day, right? And we have 5. So every single day, she's going to need how many of those? So if you do 5 into 20, that means every day she's going to need 4 pills, right? So, and that's for the entire day. So, no, it's times, I'm sorry, twice a day. So she's getting that twice a day because it's every 12 hours. So I've got my 4, multiply it by my 2, that gives me 8. She also needs to have this for 10 days, so let's multiply it by 10 again. And she is going to get 80 tablets. Boom. All right, number 7, Goober. Little Goober. He needs, he is 252 pounds. He has the concentration of penicillin he needs is 300,000 units per milliliter. His dose is 3,000 units per pound. So how many units does Goober need? So all we're going to have to do for this one, again, they gave us some extra information. This is extra because we already know. The doctor already told us he needs 3,000. That's how much he needs for that particular weight. So I'm just going to take 252 pounds multiplied by that 3,000 units per pound. And that is going to give me 756,000 units. And that's how much Goober needs. All right, number 8, Bubba. He weighs 70.6 pounds. He is 5 years old, and his owner is convinced that he needs Benadryl for allergies. His dose is 1 meg per pound. And then the strength of children's Benadryl is 12 megs every 5 mils. How many tablespoons is Bubba gonna need? All right, so this one has a lot of information on it, and for some people it can be a little bit much. So why don't we go ahead and use our bridge method for this one. So let's put our 70.6 pounds over here, and we'll just put it over 1 as a placeholder. And he can have 1 meg for every pound. So that'll get rid of your pounds there. And let's go ahead and put this one in there. We'll just figure that into the next so we don't have to bother with it later. So for every 5 mils, there is 12.5 megs. I can get rid of those units, multiply across. So when I multiply 70.6 times 5, it's going to give me 353. And then you'll have 12.5 down here. And we're left with mils. So we know this is going to be mil. So divide that by 12.5. And that gives me 28.24 mils. So don't leave it like that, because what did the question ask you for? Tablespoons. So now you have to know how many milliliters are in 1 tablespoon. And there are 15 milliliters in every tablespoon, for every 1 tablespoon. So now I just got to divide that. So 15 into 28.24. That gives me 1.88 tablespoons. All right, number 9. This one has a lot of numbers. It's 2 o'clock, 85 degrees out. Billy the goat needs an amoxicillin. He weighs 103 pounds. His temperature is 99.8 degrees. His dosage of amoxicillin is 0.75 megs per pound, and the concentration is 0.4 megs per mil. How many grams of amoxicillin are in his dose? There is a lot of information on here. Let's go back and see what they really want. They want to know how many grams of amoxicillin. They have already told us his dosage, so we don't care about the time. We don't care about the temperature. We don't care about his temperature. We also don't care about the concentration. So that leaves us with his weight, his dose, and the word grams, right? So let's go ahead and just plop that all in. So he is 103 pounds, and we're multiplying that times 0.75. And because we know we're going to grams from milligrams, I'm going to go ahead and just automatically divide all of this by 1,000. So let's see what that gives us here. So 103 times 0.75 will leave us with 77.25. And then if you're dividing that by 1,000, that leaves me with 0.077. So I'm just going to go ahead and round that up to 0.08. And that's how many grams he's going to get. All right, number 10. 40 megs is what percentage of 600? So for this one is pretty simple. So you are just going to go ahead and do 40, 600. So I lost my place here. So if I had, 600. Go ahead and maybe it was 0.066. It'll be just continuing, repeat. But they want to know the percent. We've got the decimal here. So now I just need to move that decimal place over 2 spots. So that leaves me with 6.7%, because I'm going to just round that up. All right, so now we've got what is 65% of 150 milligram dose? How many milligrams is that? So now I'm not going to work with this. I'm just going to move that decimal place over. So 0.65 times 150 give me 97.5 milligrams. All right, the next one's kind of the same thing. You're getting 25% of your original dose of 6.5 milligrams. So 0.25 times 6.5. And that leaves you with 1.63 milligrams. All right. Now we've administered only 2 grams of the patient's 7-gram dose. Which dose, or what is the percentage that he received? So it's kind of like the other one that we did up here. So we are going to go ahead and do 7 into 2. There's your 0 there. And that's 2, 14, so 2, 8, 5, 7, and this could continue and go on and on. So again, they want percent, so move your decimal place. So 28.6%. Then we get instructed to increase Buffy's 500 milligram dose by 15%. And what is Buffy's new dose? So kind of the same thing, except now we're going to multiply it up a little bit and then do a little addition. So we had 500 milligrams, and we're going to multiply that by 15%, so 0.15. So that gives me 500 times 0.15, so that's 75, but we've added it. So now we need to take that 500 plus 75 and get 575. Sorry for the ringing, by the way. That was my phone. That is her new milligram. All right, number 15. Our patient started vomiting after receiving 30 milligrams of Clavamox. The doctor would like his dose to be reduced by 30%. Sort of the same thing, except instead of adding this time, we are going to go ahead and subtract. So let's figure out what 30% of 30 is. So 30 times 0.30, and that gives me 3, gives me 9. But I'm not done yet. I need to go ahead and subtract. So 30 minus 9, that will give me 21 milligrams. All right, last few here. This is talking about solutions. So if you always remember that it's going to be this percentage here of a solution is percentage in grams over 100 mils. Okay, so if I wanted to know the concentration of a 2.27 bottle, 2.27% solution bottle, all I'm going to do is simply put that in here. So this percent right here is what I'm talking about. So it is, instead of saying 2.27%, I'm going to say it is 2.27 grams per 100 milliliters. And that's it. That is all you do. And if I want to go ahead and say, well, how many megs per mil is that? Now I just simply need to move my decimal place over or multiply it by the 100. So that would give me 22.7 megs per mil. And that is how you do that. Nice and simple. Let's do another one here. 10%. So that is 10 grams over 100 mLs. And then if I want to go ahead and do megs per mil, move your decimal place so you have 100 megs for every 1 mil. Okay, now we got 5 mil of Baytril 5%. It's pulled up in a syringe. How many milligrams are in the syringe? All right, so we already said this is going to be, well, we've got 5. So we're going to do 5 times 10, because we're doing milligrams, right? Times 10, and that's 50. And we had 5% here, so times 5 again. You have a 250 milligrams are in your syringe. 2 more. We're almost there, guys. Our patient having an allergic reaction, gotta quickly figure something out. He needs dexamethasone 2%. She weighs 93 pounds and her dose is 2 megs per kg. How many liters is she going to receive? So let's go ahead and figure this one out really quick. So we're going to move that 2% solution to 20. So this would be 20 megs per keg. Sorry, I've got people talking in the background. It's getting my brain distracted here. Now I'm messing up here. The answer is supposed to be 4.23 mils. I'm trying to figure out how I got there right now. So 93 pounds. All right, I am just going to erase this for just 1 second because I got my brain a little bit confused there. Let's start at the beginning. All right, let's figure out her weight first. So she is 93 pounds, and we're going to divide that by 2.2 to figure out how many kilograms she is. So that leaves me 42.27. And then I'm going to multiply that times the 10%. And that leaves me with 4.27, or you could say 4.23 mLs. Okay. So last one, you have a 650 meg per ml bottle. What is that concentration equal to? So for this one, all I'm simply doing is doing 650, and I'm going to divide that by 10, and that'll give me 65%. Or you could just simply move the decimal place over. And that is it. That is homework number 3, guys. So we will be having a test over some of this stuff and a few more other different things. So definitely take a look at your solutions and dilutions homeworks and your practice tests and some of the videos that I posted, because those will also be on your upcoming test as well as on the final. All right, guys, you have a good day, and I will see you later.